Hello, everyone. Happy to be here. My name is Pavol Szorad. I'm an Accenture Managing Director, originally from Slovakia. Now I reside in the United States, and I'm one of the OpenSlava co-founders. It's such a joy to come here every year and see the conference continuing and growing. This year, magical numbers that we saw in registrations. So happy for you to be here.
And hello, my name's Whitney. I'm originally from the US and now I'm with Accenture Hungary, so I've moved the other way. Yeah, this is my first time presenting here at OpenSlava, so thank you very much.
So there is a reason why you came to this presentation, which is you read the description or you maybe just walked by. But the idea is that we are going to talk to you about how we built and operated completely serverless, 100% serverless cloud-native platform for a very specific and special client. So let me set the scene. Let me set the scene with you. This client of ours, it's a hospitality company, but on the more premium side. And so what they do are these very, very premium experiences for a wide audience, mostly in the United States. But what they do is they specialize in you having a one-in-a-lifetime experience, going to something like a finals of American football or something like a finals of a golf tournament or a fashion week. And these type of experiences really can be elevated way beyond what I thought possible. So what you see here is a picture of such a setup in Arizona, and really what I saw when I observed starting this project was how they operate, how they do things, and what we need to do, what we need to change in order to prepare for a very, very big event. And so I can't tell you the name of the event, but you can guess it's one of the, or they do work for one of the world's largest sports event. And for completely unrelated reasons, I spent 5 weeks in Paris this summer, so that was very nice. And for and one of the things about these events is that they're very large. They all happen at the same time over duration of few weeks, attract guests from various parts of the world, and they cannot be moved. It's not like a, like a project, random project that has a end date, and if we're not getting the user acceptance testing done, then let's move it by 2 weeks. There's no moving this one. And these were the parameters that we walked in. We had a specific time, specific sizes, and a specific existing infrastructure to work with. However, we are able to utilize everything that we do best, and that is cloud-native engineering, and there's some ways of working across the globe to deliver these events. So yeah, events starting very soon. I believe we had less than 18 months to get it done, integrating with a lot of existing systems. Now, we decided that this is the way when we will build it the right way. As I mentioned, there was brownfield, but we could create a really greenfield infrastructure and application, and we decided to take it from the enterprise level. And from the enterprise level, what it means, you basically break down a very large problem into manageable chunks. And what we've done is that we decided to create this vision called the Enterprise Experience Platform. The Experience Platform that creates what you saw in the keynote today, a real-time experience combining multiple data sources into something that wasn't possible before through various channels. And all of these systems orchestrated and communicating together. We created using domain-driven design. Across the whole enterprise, we created what we call the enterprise domain model. So again, logical, manageable chunks of functionality, where we basically said, these are the things that you have in your ecosystem, but these are the ones that we will be taking care of as part of this project. a part of transformation. What you see is I abstracted the ones that you don't see any text in there that weren't needed for us. But the ones that you have here go basically from a life cycle of an experience. You buy a ticket, the ticket has a specific availability, pricing, or not a ticket, you buy a package but can contain a ticket. And then you fulfill it, meaning that you can enter a venue, you have some communications about that, maybe you have a transportation package, and we know about you as a customer and we know about you as a guest. This allowed us to really focus on the engineering of the important parts. So we went through a full product exercise, and you were seeing screenshots from Confluence, but really, what is the domain model for our enterprise platform, and which domains then we have implemented? In the end, in the greenfield, 100% serverless, AWS-based solution, we ended up building full 6 domains, operating full 6 domains. One of them was the order domain, which, if you want just a description for one domain, it was the source of truth for promises made to customers via a purchase. Very, very important thing, because it allowed us to kind of take a line from business all the way into development, into production, and still keep that single line of thinking that could be explainable to someone like a CEO who really doesn't care about an IT shop or their IT even so much. They care about business and what outcomes do I have. So we used this, and it saved us. It saved us significantly because we're entering our first story time for today. The story time is that since we had the domain model compartmentalized, sorry, I probably said it wrong, but we had different compartments, and we knew which one we are responsible for and which one are responsible our partners for. We could logically focus on our part and integrate with the domains of where someone else is responsible. One of those domains that someone else was responsible for was the guest registration domain. You would guess that it is important to get registered for an event. You all have registered for this event here, right? That means that without registration, there's no fulfillment. There are no tickets falling through. You don't have a QR code to enter. And 2 weeks before the event, that vendor said they will not do their domain, just 0. However, since we had integrations that were decoupled, event-driven, we're able to quickly replace that domain with a really hacky solution, I need to be honest. But what someone has been working on for a year, we're able to hack together in a semi-manual way in 2 weeks without sacrificing all of the deadlines we had, without sacrificing all of the timelines we had in terms of engineering, product, and just fulfillment, and able to plug into a hacky solution in the 11th hour. Okay? So domain-driven design, product orientation, having the right team to do it gives us a lot of flexibility. Next, what we had were, the parameters of our solution. We had to do very difficult and specific architecture solution. So we had some guiding principles. We wanted to be near real-time, same as Kai said. We wanted to be flexible, decoupled, elastic, durable, cloud-native. You can ask ChatGPT to generate this for you, and you would get similar answers. This was out of workshops we built. But we used these guiding principles throughout the decision-making. And in the end, we did actually ended up with fully serverless architecture. So we built everything on AWS, so we're abstracted from our problems with infrastructure, managing infrastructure. We built everything on AWS Lambdas, function as a service, so we had no Kubernetes pods, no containers to take care of, to restart, to have huge operation teams for. And we used all of the persistence layer also as serverless, in this case, DocumentDB and some others. we decided that it is quite important to do changes in production that we can version control and manage as things are going on, as an event is going on. And we had 100% of our platform built in IAC, in this case in Terraform and TerraGrunt. I must say 100% because it's limited to 100%. It's 99.99999 because there are like 5 toggles that we had to do manually because there isn't a Terraform thing for it. But, you know, approaching 100%. And then we selected a Kafka version that was MSK, Managed Service for Kafka, Amazon solution. I would love to use Confluent, didn't happen this time. And we use what AWS provided natively. We wrote this all down, had it all approved, wrote down as we went, so that every time we were questioned, why did you do this or that, we tied back to an architecture decision record and a solution decision record, and in the end, back to the guiding principles that were approved by the transformation board, including the CEO. And in the end, this massive system was extremely simple architecture. We have some entry points, we have some functions in Lambda, we have some persistence, DB instances, DocumentDB, and we had some Kafka underneath that across 3 availability zones and replicated to a cold region, so across 2 regions. We had some additional auxiliary things like observability, which we'll hear about in a moment, some parameter store, some logging, and some web application firewall on top of that. Simple as it gets, which gives us speed. Underneath each Lambda, there was much more, obviously. But on the top level, we were able to abstract a lot of stuff that you normally have to think about and take it as a service. So in the end, yes, we had to do identity through Cognito. We had to do some firewalling, some API management, and create API endpoints, so different Lambdas doing different things, writing to various Kafka topics. But the architecture is just so simple to look at and so simple to use and operate that we came up with. Is the best one? It was the best for us. Story time, number 2. With unlimited scalability come some issues. In our case, we had our system where we had some product content stored, think text and images and descriptions of the packages you can buy and the tickets you can buy. We were serving that to the website. Because we used a specific tool for product content, a content manager, we were serving them that content through Lambdas and making it available to whoever wants to listen to it. And one of the things that ended up happening was there was a website with a specific front-end component that went into an infinite loop. And we had this discussion, and we had like some type of a rate limiting on the gateway and maybe even on the firewall. But we set it very high on the request of that other team, on the request of the client. And what ended up happening is that they did hit that limit. It was something like 75,000 requests per 5-minute window. So obviously, our fail-safes triggered, and we stopped all of that traffic. And so now no one could see any product content anymore if they browsed the website. So immediately I got a call. We had to jump on a meeting, and we were able to fix it, change the limit, and they were able to fix it on their side. But then in the evening, I sat down, and I opened the AWS console, and I went into the cost explorer. And I opened compute, and I opened Lambdas, and my boss is pinging me, and I was like, I'm sorry. It was a really bad day. On on a month, our compute costs tripled. They went from $30 to $90 per month. So in the end, the Lambdas are so efficient that our cost of a massive platform for a month are less than you buying a Raspberry Pi here. That's the compute cost in a fully serverless architecture. Love this story. I think, Whitney, it's over to you.
Yes, yes. So you have this simple architecture, you have this need for speed and flexibility, and you have 18 months. So how did we then get into the operating side and getting fixes into production at record speed in the middle of the day with single modules being able to be deployed without affecting any other? Gen AI and Copilot is our answer. So we used Copilot to automate all the testing, and this was built into the pipelines as you're going along. So you have Copilot was enabled for all engineers, all product owners, right? And it was used to build the BDD testing and scenarios. And so it was great, easy, plain English text that you could build in Copilot, and it could come out and create the case for you. There's obviously, it's not a first time win, right? So there's iterations through, there's some manual intervention in there, but the amount of time we were able to save, because we don't have much now, there's no like, hey, can we have an extra 3 weeks? It saved us a lot. And a lot of sanity, and just the ideas Copilot can come up with, just something we didn't think about. Like, oh, actually, have we thought about this case? Have we thought about this one? So in each domain, it was built this way, and because you have engineers, every engineer working and pushing code within their domain, you had them building it, but they knew exactly the model or the tests that needed to be done to ensure that their area of their code is working efficiently. Okay, so now we have the domains built, the domain testing built, the testing is there. We want some end-to-end as well, but again, we're a little bit short on time, so Copilot is there. So we're able to build this, somebody puts in an order, this whole end-to-end functionality, but we're not having to build it from scratch. We're able to take these domain BDD tests and kind of puzzle piece them together with how we need to build our end-to-end testing. And this is built into the pipeline. So once it's there, it's there. The catch is here, if you're needing to change any functional code, any logic within the functional code, it's gonna fail on your test, your BDD test, because you need to go in and change quickly. This caused somebody a massive headache until they realized, like, my code is awesome. It's hitting the functionality. Why isn't it passing? Like, oh, crap, yeah, we need to go in and change this quick BDD test, and it's going to run through. And this really gave the confidence to your developers and your DevOps team that nothing I build or try and push is going to break the logic, because it just simply won't pass these 312 tests that it needs to pass to be able to get pushed. And this is in every environment. So all your environments have this. And this is where the speed and flexibility and the being enabled to really come into play come the crunch time when the games are happening. Yeah, so DevOps experience. I mean, a lot of it is there that we've created this architecture, but we also created this tailored and tuned DevOps experience that you might not get in a lot of your other projects. I know I certainly hadn't. So with just kind of the background with domain teams, they're 100% owning their infrastructure and functional code. 100%, it was theirs. At the beginning of the project, they're asked, like, we want you to do it. There's no like, okay, you're level 11. Like, maybe get your code passed to him and then on to him to make sure it works. Like, we're so sure with this automated testing that we have that we're able to say, hey, everybody's voice can be heard here. If you think you know the way to do it, build it. And actually, you can push a single unit of code or single module, and you're not, because it's decoupled, you're not affecting anything else in the system, which is a great thing to have. So your automated testing, you had your BDD test, your Sonar Cube, there was the whole list, right? So this really enabled and empowered the independent work through these 18 months, but then also come the game time. And because you had developers, every developer within their domain intimately knowing the code, an issue comes up and they know exactly where they're looking, right? You're not having to guess, oh, but Katie kind of did it. Let's see if she's available. Like, let's wake her up. No, everybody knows the code very intimately, which really came into handy come the turn. You have the quick delivery and turnaround as well, because they're not having to search, like, how did she build this? How did it work? They know how it works, so you have that, and then obviously this is coming into that to the instant bug fix and triage into production when you needed it. So yeah, here's just a quick picture into kind of how the DevOps experience was, how the infrastructure was set up through here, how everything's coming into the automated tests. There were obviously procedures put in place, so open your feature branch, there's PRs, right? So there is this process, but it's a very independent process that doesn't need a lot of oversight from other people. Yes, so the decisions and what their decisions at 18 months ago led to, and it led to the purple side, which is a lovely side to work on, but I don't know how many of you have been on projects. I know I definitely have, where you're more on the black side, so you have this centralized control. You have scheduled releases, but to even get into the schedule of the release, you have about 10 pages worth of paperwork that is going to be checked by 3 different people, and you're going in and like, hey, Andre, can you please, you need to approve this because I'm going to miss my deadline and my scheduled release have to be in 2 weeks' time, but it's ready. Like, okay, are you sure? Like, can you show me your code? Where's your testing? Like, there wasn't this process. There wasn't time for this process because this is happening in real time. So you don't have this centralized approval. You're like desperately, I hope you're having a good day. I caught you after a coffee. Please approve my request. You have this built-in security. You have this speed and flexibility, and you're able to do it on demand. So again, there's not many projects that you can come to that you're pushing to production at the peak usage of this application, right? A lot of times, pushes into production are happening from your 9 p.m. Through your 4 a.m. when there's not many users it's going to affect. Yeah, and you're able to do this autonomously. So you do need your PR. 2 people do have to go in and approve it. This was the only manual part of it, so there is a little oversight there. But that's it, right? So it was great in this area. Yeah, so story time, this is a good one. So we have a developer, she's running some pipelines, it's gonna take, she has a little time. So what do? You multitask and you do your mandatory security trainings, as you do. And okay, you don't have to raise your hand on this, but some people kind of click through their mandatory security trainings. It's a checkbox activity. I am 100% guilty of this as well, but now I won't be, so maybe you won't be after this either. Okay, so as she's going through her security training, paying very close attention, maybe this brilliant idea, she should check how her code is coming to the security training she's watching, make sure it's up to standard. Okay, hers was great, but you know, we have some other things feeding into our system, some third-party applications. Let's check how they integrate in, and are they safe? Are they not? So with very limited digging, nothing that needed to be done on an incognito window, she's able to see through this third-party applications in plain text API keys to all our environments. Yeah. So pay attention on your security trainings, check what you're doing, and if your code's up to standard. So plain API keys on the web, plain text, doesn't take a genius to figure out what's happening here. So obviously, immediately we're on the phone, security alert is raised at the top level, and once the decision is made, so there's some decisions, how did this happen, but once the decision is made, we're gonna rotate our API keys, and we'll investigate later from point of decision to over all 5 environments, API keys rotated 15 minutes. Right, and so this is just something, again, that Yeah, you need to just be aware of what's happening, but also double check work, third-party applications coming in, because this is one of the most, and we'll get to a little bit later, but one of the events with the most hacked or attempts to hack into the system. There's a lot of data, personal data there that really needs to be there. So we know that a lot is happening. A Lambda goes down, a third-party application decides to push something into production that hasn't really been tested. They don't quite know what's happening here. How do you catch it? And how do you actually, sometimes I feel like monitoring gets overlooked a little bit because, okay, it can be slow, you can miss some things. It depends on the environment and where your application is, but sometimes the effects aren't so big. So, okay, I see an alert coming in, but I want to drink my coffee while it's hot. Like, how is this working? But this wasn't the case. We needed to be able to catch things as they're happening in real time to be able to make those bug fixes, which our developers can do with quick speed, flexibility, autonomy, but they can only do this if they know there's a problem, right? So we decided to use Datadog, and it was our first kind of point of entry with monitoring. We were forwarding the logs from CloudWatch, so CloudWatch was used as well, but more for some investigation. And then Quicksight is there from a monitoring perspective. We were more seeing how the air fed into the data and how it was affecting the air there. So your morning view, dashboards. We created a dashboard that had every single monitor and alert per environment. So this is a production environment. I can log in the morning and know within 2 seconds how my morning's gonna look, and I don't have to search. I'm not clicking around like, okay, let me check. A, B, C, D, E dashboard, it's here, it's for me. Pavol comes, hey, how are we looking? Actually, we're at 34 for 34, we're in the green. 2 minutes, we have a red. We have one red, but it's okay, and I know exactly where to look. And actually, I can click in here, and it takes me straight to the monitor. So it's very easy to navigate. Anybody, even without the Datadog experience, I could send them the link, and here it is. You can see for yourself. So the dashboards were really key for doing this. And for each domain, we also created individualized dashboards that had the information that we needed to see on it. And we needed to see without having to guess what's going on. So they were Datadog offers very good out-of-the-box solutions for dashboards, but we created customized one that really worked with our domain teams. So on the next slide, you'll see an API and a Lambda dashboard, and we could put a lot more information here, but we worked with the domain teams of what you need to see and what is going to be the issue. Right? Lower on, I can scroll and get some of like the live logs coming in. I can see what's happening. But I also want to see what's in red and what's in green. Maybe it hasn't quite, so that these aren't connected to the alerts, but they're giving us idea when the alert's coming, right? So I could go in and be like, hey, there's a timeout coming. It hasn't hit our alert yet, but our system should be having no timeout. So just keep an eye on this. Another thing that was easy to see and that Datadog is great at is it has the AI integration with Watchdog Insights, which was really good. So we have alerts coming in. Are these kind of one-off things, or is there actually something happening, a trend happening? And I'm not having to click through. I hope you've never had to do it either, but I have to click through logs and what is feeding back from this log. Watchdog automatically does this for you, no extra setup. And you can see where there's an issue, or if there's no insights, then yeah, it's a one-off. Maybe we can look at it, but it's not something that's continually affecting the system. So a couple story times, they're very quick. From alert to fix into production. So we're, I think, a day or two coming up to their most used weekend, so the most customers that they have, and our DocumentDB just can't handle it, what we have here. So we're having alerts. We have, I don't know, like 40 alerts coming in from it. So, okay. So here we're going into AWS, and we can see the CPU is just, it can't handle the amount of traffic that's coming. So, okay, do we do the root cause analysis, or do we just put cost out the window for a couple of days and get through this busy period? And obviously, you can see this is what we decided to do with this. The ceremony happens, their big weekend happens, there's absolutely no issues, no crashes with that. So again, the next one, we're having a high 400 errors on an endpoint, and I can tell the domain fix within a minute, because Watchdogs just told me that 204 out of your 223 issues are coming from this client ID. I didn't know who they were. Of course, the domain team did. This was the great thing. I didn't have to know the intimate area of everything. They were experts for this, and a lot of them. And here's the IP addresses coming from Paris. The rest, actually, they're not even split around. They're only coming from here. Someone in the domain knew exactly. Within minutes, she knew exactly, and she was working with the third party to fix what was going on there. And then my last, so I want you, if you can see, to just see the timing of these teams. They're just team messages. Here, again, we're getting timeouts on this Lambda. Okay, within a minute, I'll have a look. I know what's happening, I'll work on a PR. This is within a minute. Okay, somebody else comes within 5. Like, shit, we need to get this sorted. We can't have this timing out. I'll create it manually, and with 13 minutes, sorted. The PR came a little bit after that, but having that insight and your dashboard set up and your alerts set up to really know what's happening within your system, it was key to making everything else that was built ahead of time successful.
So there's much more going into building and operating, but so far you heard about guiding principles, meaning architectural solutions, empowering developers to develop, operators to operate. But we had a lot of preparation for the operational window, right? Like the things are happening, we are prepared, there's this time frame that we need to be ready, and there are much more things going into that. So let me talk about that a little bit. We had security and incident planning. So similar how you heard the story about a security incident that turned out to be in the end, nothing was leaked. We had to go through specific steps to raise that level 1, to get the right people on the call, to have the right decision, and all of these had to be created, written down, create playbooks, but also we ran tabletop scenarios, kind of like pretend that we are being hacked and you get this notification, etc., etc. And we ran it with various levels of management. Over the course of the operational window, we had 0 significant incidents on the security side, and just looking at the firewall, we have prevented 11.5 million attacks. Basically, daily we saw spikes, and we were working with the virtual security operations center to get them open a case and look whether that or this IP is malicious and whether we are being attacked. And we were, so much. There are more things about like various cyber threat intelligence operations, a whole preparation team, but bottom line, security and incident planning, you have to do it if you're facing such a threat, such a set of threat vectors as we have.
And we had a dashboard for this as well, where the information was given to the security team within seconds.
Additional thing was, during the operational window, this system cannot go down. No, it absolutely cannot. There is no way that you would be queuing outside of OpenSlava entrance and your QR code doesn't work. So we were the highest tier in terms of criticality, and we architected that system based on our guiding principles for that RPO, RTO metrics for resilience. In the end, we did reach 5 nines of availability. As I mentioned, we had a free availability zones in 2 regions. And we also have hourly backups. We can go faster than hourly backups, but that was at this point cost prohibitive, so we didn't do it. And in the end, we did not face an issue. Interestingly enough, you are probably all aware by the largest IT outage in the world that happened, a few months back. we were on AWS, we were unaffected. We had a small outage on our DevOps platform, but that was it. I would like to say we would survive such a thing on AWS. Hard to say, but we architected towards these numbers. So getting ready for a big event, specific time, specific requirements, still requires thinking. So we have heavily used Gen AI to inspire us in various places and help us with the engineering. But in the end, it really comes down to making good decisions, documenting them, sticking to them, evaluating them, and empowering various teams that we had, the developers across many, many time zones, across 5 countries, 6 countries, including Danubia here from Slovakia, Hungary, and Romania. It takes a lot of resilience on the people side, it takes a lot of resilience on the tech side, but in the end, you can then enjoy a view like that with a little of champagne. So thank you, and we'll go over to the questions. So did you have to train Copilot to be able to generate relevant and valid use cases for your domain modules? We did a lot of testing and prompt engineering. In the end, we had a small repository of prompts that were like quite long, and they were around the, it's like, please generate a BDD test for this domain, and these are the parameters of what I want. Imagine this is the context, imagine this and that. I don't have an example from the top of my head, but we did not train the model. We had a pre-saved prompt that worked for us, that got us 85%, 90% to where we want to be, and there was then manual changes to the BDD tests. Yep. How big team do you need to build system like this? I think in the end we had maybe a dozen people in the United States, about 24 in Mexico, and then about additional dozen operations and leadership. So it's roughly like that. Obviously, this ebbs and flows depending on what phases you are. You need a smaller team to do domain-driven design. You need a smaller team then to actually operate. Quite large team to develop. It was various sizes of teams, various times. I've mentioned the cost of compute. Can you share DB cost? DB cost is not that elastic as compute. And it was by far like over 50, 60, 70% of the total cost was the free availability zones of DocumentDB across 5 environments. It was a lot, and this was pre-discussed and pre-agreed with the client that this is how it's going to be. Compute cost, $30. 100, I don't know how many 100 times more was the DB cost. It was very big, but still we were just our total cost was below the compute cost of their similarly sized legacy system. And that's where we made our case, right? We had very big databases compared to our compute, but all of our platform was less than their existing compute with similar sizes of transactions. That was the powerful moment there. Is this a monorepo? And how do you make sure it's a consistent version out with all of those Lambdas? Question for you.
Yeah, I can do it. So we did a lot of the versioning through Terragrant as we're pushing. So it's part of, as you're making a change to the functional code or wherever you're making it to, you're updating the version, which will update in the, as people are pushing their PR or making their PRs as well. So, and it wouldn't go through if the versioning wasn't right or didn't match up. So it was caught in there.
What was your approach to hotfixes during the live phase? Did you work in the 9-day shifts? So we had a huge coverage of from Europe to all the way to Pacific time zone in the US. And then, yes, we had shifts. So we prepared, we had shifts, that's what we did. Sometimes it was, we had to stay longer. It was definitely a very, very intense project for all of us towards the operational window, but we prepared well and it worked out well.
Yeah, it worked great.
Last question. I did not say this was this particular event, but I did enjoy the Slovak house that I attended randomly, not related to the project at all. So that was nice. I will take questions outside for a moment. Thank you all. I appreciate you being here.